This is the memory allocation and garbage collection activity in Python. I have the folder open here along with the README file. The first thing that you'll want to do is research, and please do this on your own. If you haven't done that yet, go and pause the video and do some internet research. You want to research memory allocation and garbage collection for Python. Take some notes, make sure you understand how things work to the best of your ability, and then come back. What we're going to do is basically talk through these questions down below. So the questions here are: how are our objects allocated and deallocated in memory? What's the difference between managed and unmanaged? Are there design patterns that can help us? And how do you interact with the garbage collector directly? So to help us out, let me just create a file here, my file.py, and let's create some code here. So we'll say my value equals 3. We'll do a function, so we'll say do something. And let's create some values. So we'll say a equals 2.0, b equals test. Let's do a for loop. Just do a range of 0 to my value. And then we'll print out B. Now that we've got that, let's just execute this real fast. We'll say do something, and let's have it return something just to make it a little more interesting. Let's return A. We'll say my value equals do something. All right, so we've got some code here that we can use to answer these questions. So let's start off with the first one. How are objects allocated in memory by a programmer in Python? Just like in the other languages, there's basically two ways this happens. The first is with an object literal or an inline literal. 3 is an object literal for a number or an integer. 2.0 is an object literal for a number or a double. Test in double quotes, the double quotes indicate an object literal for a string. So each of these are object literals. We also have true and false for booleans. So there's several object literals that we can use to declare constant values inside Python. In addition, anytime we construct an object, that would generate an object in memory. So if we say C is some new, let's say I've got some new class, and we create that with calling the constructor, this constructor will initialize it. So it's the underscore underscore init underscore underscore method that will also allocate an object in memory at that time. So again, two ways to do it. One is constructing an object through the constructor, and another is through object literals. Those both allocate values into memory. How are objects deallocated? Well, deallocated happens in scope blocks. So the scope blocks are defined in Python by indentation. So for example, A and B and 2.0 and test are all defined in the scope block of do something. They're all in that level of indentation, which means when do something is completed, at that point, 2.0 and test and the values or the variables A and B are now eligible for garbage collection. So that's how we define those. I, on the other hand, is available only in this block. Now, Python's a little different than other languages. I will actually be available to us later on, but that is basically the scope block. So my value doesn't have a scope block, which means it's available everywhere. So scope blocks are really determined by the indentation level. So if I had do something inside a class, or I had another function here that would be a helper inside, helper func, anything declared in helper is only going to be available inside my helper function, which means C is not available outside. C is declared inside this helper function, and so the scope is not available. C will be garbage collected as soon as the helper func is completed. So again, it's scope blocks, and scope blocks in Python are defined by indentation. What's the difference between managed and unmanaged and ensuring deallocation? So I'm not going to get into this because generally we don't do unmanaged memory in Python. You can do it. There is a way to do it. It's strongly discouraged, highly discouraged. So we're not going to answer that question today. If you are interested in it, I recommend doing some research on your own. It is an interesting problem space, and the way Python does it is very different than other languages, but it is worth looking into at some point, but I'm going to skip those questions. The next is, are there design patterns or specific types in the language that can assist in garbage collection? The answer is yes, to a degree. So we can do something much like the disposable pattern or the auto-closable pattern that are in C# and Java, and now the disposable pattern in TypeScript. We can do something similar with a context manager. So a context manager in Python is basically requiring us to create an exit or an enter and an exit method. So let me give you an example. Let's create a class called myClass. And if we want to implement the context manager, we would create an enter method. And I'm just going to pass for now, just so we can see what this looks like, as well as, oh, and I need def, as well as an exit. And there's arguments that go in with it. I recommend looking at it to see more information. But now that we have this enter and exit, what that means is we can use a with block. So we can say with my class, this is going to create an instance of my class as, let's call it D. Now we can do something with D. What this means is the with block, as soon as it enters it, it calls the enter method. And as soon as it's done, it calls the exit method. So as it's allocated and as it's deallocated, we can now do something specific here. So this might be for a database connection. In enter, we could open the connection. Exit, we could close the connection. Same thing with a file object. We could open it with enter. We could close it with exit. So there's different ways that we can do this, but this with block, we'll use a context manager to do that. We've probably seen this already with files. You can do this with Python APIs for opening files. So with open, right? So the open method will return an object that is a context manager and allows us to use the enter and exits. So that's basically the type that we can use as a context manager in Python. Finally, can you interact with directly with the garbage collector? Yes, you can. You can import, it's a type called GC. The GC class or module allows us to basically interact with the garbage collector. It has methods that allow us to request garbage collection runs, but like the other languages, it's a request. It's up to the garbage collector to decide truly when it's time to run and what needs to happen. But we can interface with it directly if we absolutely need to. In general, if we find we need to, we've probably done something else wrong. So do a little bit more research, definitely do some more deep diving into this, but that concludes the memory allocation and garbage collection activity in Python.